The next problem is important because this problem is in this problem is from a chapter called polynomials, which is quite possible you get at least two or three problems from this topic.
Hello, guys. Welcome to Cheenta School of Statistics and Data Science. We are a team of extremely passionate teachers, researchers, and statisticians from the top universities of India and USA. Our mission is to help you curve your career in statistics, data science, and machine learning. To book a trial class for your preparation courses of IITM MS, ISIM Stat, and CMI MSC Data Science, check out the first link in the description below. If you're enjoying the video, show some love by liking the video and subscribing to the channel. We welcome you again to this passionate community of budding statisticians and data scientists. Let's enjoy the rest of the video. Stay tuned and stay blessed.
So you have a polynomial px which looks something like 10x to the power 400 to a x to the power 399 plus b x to the power 398 plus 3x plus 15, and a b will belongs to real numbers. It's given that this polynomial is divisible by another quadratic polynomial which is given by x square minus 1. So the first problem is find a comma b. After you find a comma b, the second part of the problem, and this is a very important problem. If you can solve this problem, I'm pretty sure you will get a brief idea on solving problems that looks like this. Of course, you'll need to have a lot of practice, but okay. So if Ri is less than 400, greater than equals to 1, are the roots of px, then find the value of summation 1 by Ri. So you need to find uh, the the reciprocals of the roots of this polynomial. Of course, I will go from 1 to 400. So this is 400. Is the question clear? Do you have any questions? Can we easily find A and B? If you can find A and B, try to solve part 2. So the first part is simple. Because x square minus 1 divides p of x, from here you can say that p of 1 will be 0 and p of minus 1 will be 0. This is because x square minus 1 is equals to x plus 1 times x minus 1. But if this is qx, q of 1 and q of minus 1, both of them are 0. So this is the region, because this part is inside this. If this is the case, then this should also be the case. The second part is, okay, so if you solve this, substitute these values in the original equation, you will get a equals to minus 3, b equals to minus 25. It's just a simultaneous equation with two variables a and b. You just easily solve it. Okay. And the second part is, there are two ways to solve the second part. In fact, I didn't do the way you just did. I did in a different way. So whatever. So the first way, let me write down the first way. Say this is my a. So you need to find summation 1 by Ri. Ri are the roots. Roots of p of x equals to 0. Of course, I is from 1 to 400. I will abstain myself from writing this, but it's quite understood. So what you can write is simple. This is equals to summation. So in what way will you get this Ri? This Ri is something like R1, R2, R3. You have Ri here and you have R400. So this is the product. So I'm writing this down, this whole expression. I'm writing this whole expression in a way so that you can substitute the known values. This is nothing. This is just the product of the roots, which you already know. Now, what you can do is um, you can write R1, R2. There will be Ri minus 1. And there will be Ri plus 1 into R400. It is easy because what you can do is this gets cancelled. This will get cancelled. You will have a 1 here. You will have this Ri here. Right? Now, this product is uh, 15 by 10, I guess. So this is 15 by 10. 15 divided by 10. So you'll have a 15 by 10 here. So what I'm doing is I'm taking this out because this is a constant. The product is constant. There'll be 1 by 15 out here. And here you will get this expression. Now, this expression is easy to find. This is nothing but this will be 10 by 15, of course. This is nothing but product of the roots taking taking 399 at a time. This is nothing but just 3 by 10. It's 3 by 10. But because this is taking all at a time, which is the product, this is taking uh, 1 less than all at a time off. Then this will imply that 1 by Ri are the roots of 1 P of 1 by x equals to 0. Is it clear? This is the second way how you can solve it. Now, what you can do is find the expression of P of 1 by x equals to 0. From here, you can say that it's something like 10 by x to the power 400 plus a by x to the power 399 plus b by x to the power 398 plus 3 by x plus 15 equals to. So roots of this equation are 1 by Ri. This is the sequence of the roots I from 1 to 4. Now, if you reduce this, you'll find that this is something like 15x to the power 400 plus 3x to the power 399 plus bx how much square plus ax plus 10. So what you needed to find is the value of 1 by Ri. But 1 by Ri are the roots of this particular equation. So if you can find the sum of the roots of this equation, you will be indeed finding the value of summation 1 to 400 1 by Ri, because 1 by Ri are the roots of this particular equation. So the sum of the roots, this is the sum of the roots. And this is given by minus b by a, which is minus 3 by 15 or minus 1 by 5. Neither way you'll get the same value, of course, minus 1 by 5. This is the second way how you can solve it.